What's up everyone, Patrick here, welcome back. Moving on to the next question. We have to find all the values of x satisfying this inequality here. So we got 4x minus 3 over x minus 3, and we have to figure out when is that rational expression right there going to be greater than 5. Now to solve this, what you want to do is actually bring everything to one side like we usually do with a regular inequality. So this 5 here, I'm going to bring over, so we'll have minus 5. And we got to figure out when is this greater than 0. And then what you want to do here, this 5 here, I'm actually going to put over 1, is you want to take these two expressions and combine them into 1. So to combine these into 1, notice they're both fractions. We would have to get a lowest common denominator, which would be the x minus 3. So that means this top here. We have to multiply by x minus 3. So we would end up with 4x minus 3 minus 5 bracket x minus 3. And that would be all over x minus 3. And we got to figure out when is that going to be greater than 0. And then from here, simplify the numerator. So we would take this negative 5, distribute it in the brackets. So we would have 4x minus 3 minus 5x plus 15 all over x minus 3. Got to figure out when is that greater than 0. 4x minus 5x, that gives us negative x, and the negative 3 plus 15 gives us positive 12. That's going to be over x minus 3. Figuring out when is this going to be greater than 0. So we could leave it like this. What I'm actually going to do, I'm going to factor out this negative, make it look a little nicer. So we'd have an x minus 12 up here, like that. Actually, another thing we could have done is wrote 12 minus x up top, but it's okay, I'll just leave it like this. So from here, what you want to do now is take all of the factors in this rational expression. You want to create a sign chart. So what we're going to do, notice that you first have to find out all of the x-intercepts and all of the vertical asymptotes. So notice that x equals 3 is a vertical asymptote, and then x equals 12 is an x-intercept. And you want to create a sign chart with those x values. So we're going to go from negative infinity to 3 to 12 and then to positive infinity. So I'm going to create columns here for each of these. If there was more factors, then we would put those extra x values in the sign chart. But there's only 2 factors in this case. And then what you want to do, we're going to pick a couple of x values in these intervals. These are the 3 intervals we're working with. And then we want to figure out what is the sign going to be of these factors. Now this negative here, I'm actually going to put with the x minus 12. That's what I was saying before. We could write this as 12 minus x. I feel like maybe our chart then would be better if we wrote 12 minus x, or it would look nicer at least, but let's just keep the negative there. We already went that route, so 12 minus x and the negative bracket x minus 12, those are the exact same thing, so it doesn't matter which one you write. And then the x minus 3, I'll write over here, and then we're going to combine them into the actual function that we're working with. All right, so now what we do is we pick x values between each of these intervals, between these values here in these intervals. So between negative infinity and 3, we could pick 0. Between 3 and 12, let's pick 5. And then between 12 and positive infinity, let's pick 15. So if we plug in 0 here, we'll have 0 minus 12 times negative 1 would give us a positive 12. 0 minus 3 would be negative. And then positive divided by negative, positive numerator divided by negative denominator, that would give us a negative value for the function. If we plug in 5 minus 12 is negative 7 times a negative 1 gives us positive. 5 minus 3 is positive, so those divided by each other would give us a positive value. And then between 12 and infinity, positive infinity, we pick 15. 15 minus 12 is positive times negative 1 is negative. 15 minus 3 is positive. This divided by that gives us negative. And we're trying to figure out when is this positive? When is it greater than 0? Well, it's going to be greater than 0 in that interval right there. So the final answer for this question is that x is between 12 and 3. Not inclusive of them because it's a greater than 0 over here. Now you got to also be careful if this is greater than equal to 0, we wouldn't include the vertical asymptote. The way that this looks, if you want a quick review from advanced functions here of rational functions, so we got 12 as the x-intercept, then we got an x value of 3 as the vertical asymptote. And then if we plug in 0 for x, we would have positive 12, right? 0 minus 12 is negative 12 times negative 1 is positive 12 over negative 3, which would give us negative 4. That would be the y-intercept. And then we'll have negative x over x, so the horizontal asymptote would be at, negative 1. So that would be over here. Right, this is not as important, the diagram, but if you're wondering how this looks like, so it's like this, and then goes through 12, and then we got this vertical asymptote here, so it looks something like that. Right, so it's basically this part and then that part. That's how this function looks like. So when is it greater than 0? When is it positive? It's going to be positive right here between 3 and 12. But if they were asking when is it greater than or equal to 0, notice that it would be from 3 to 12 inclusive, because 12 is the x-intercept while 3 is the vertical asymptote, so it's never going to hit that x value of 3. Right? But it is going to equal 0 at that x value of 12. So that would be the answer if it was that right there. So that's what can make rational inequalities a little tricky. But because it was that, it's just this over here between 3 and 12. And then in another format, we could say x is element between 3 and 12. Right? So either of these formats, that is the final answer to this rational inequality.